In this online lecture, we're going to discuss some structural details of H2O. So the first thing we should notice here is this would be the condensed version of H2O. This right here would be the Lewis dot structure of H2O. We see the two sigma bonds and the two lone pairs on that oxygen. And in order to make sense of the bonding in water, let's determine the hybridization of that oxygen. Remember, carbons are not the only atoms that can be hybridized. We learned in another online lecture how to quickly calculate hybridization, and that is to first determine the steric number. And in this case, this oxygen has a total steric number of 4, which means this central oxygen is sp3 hybridized. So let's get a better look at that. Remember, all sp3 hybridized atoms have 4 sp3 hybridized orbitals surrounding them. And at this point, remember, the orbitals would be 109.5 degrees apart. But now let's place our atoms and our lone pair electrons. One of the bonds in this molecule, remember, is oxygen to hydrogen, which means to conceptualize this bond, you have the 1s orbital from the hydrogen head-on overlapping with the sp3 orbital of the oxygen. That, of course, is a sigma bond by definition, and that explains one of the bonds. The same thing could be said for the other OH bond in water. Again, it's a head-on overlap of the 1s orbital of the hydrogen and the sp3 orbital of the oxygen, which leaves us with 2 hybridized orbitals. That means the lone pair electrons are in each orbital. One would reside here, the other lone pair would reside here. Remember, 2 electrons at most could fit in an orbital. Now remember, we know that lone pair electrons take up a lot of space, which means the bond between the 2 hydrogens is not going to be 109.5. These electrons are going to squeeze them together, so the actual bond angle is 104.5 degrees. Remember, this is what VSEPR theory teaches us. Now, let's get a good look at this oxygen's new electronic configuration. Remember, oxygen is atomic number 8 on the chart, which means he has 8 electrons to be neutral. 2 electrons would fit in the 1s. Another 2 would fit in the 2s orbital. And to bring us to 8, this would be 5th electron, 6th electron here, 7th electron, and then we'll double up to get the 8th electron. And remember, this is the unhybridized electronic configuration of oxygen. So let's hybridize him by first taking out his electrons for a minute here and combining the s and the 3 p's together to make an overall sp3 hybridization. Now remember, we took out the 6 electrons. Let's place them back in orbitals, but this is how they'll be placed. Notice this matches the structure in the upper right. Remember, we have the 2 sp3 orbitals that have the lone pair electrons. That would be these sp3 orbitals right here. And we have the other 2 sp3 orbitals making bonds with hydrogen. So therefore, they would only have 1 electron in them so that they can overlap with the electron in the s orbital of the hydrogen. Make sure you remember the structural details and orbital arrangement of the H2O molecule.